Electrical wiring is a fundamental aspect of building construction and maintenance. It involves the installation, maintenance, and repair of electrical systems that provide power to various devices and appliances. Understanding best practices for electrical wiring is crucial for ensuring safety, efficiency, and compliance with local electrical codes, particularly in areas like Henrico County vaults. This narration will delve into key aspects of electrical wiring, focusing on safety standards, common wiring methods, and best practices for various applications. Safety is paramount in electrical work. Electricity can be dangerous, and improper wiring can lead to electrical shocks, fires, and equipment damage. Therefore, it is essential to adhere to safety guidelines and regulations. Firstly, always to energize the circuit before starting any electrical work. This involves turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is indeed energized. Secondly, wear appropriate personal protective equipment or PPE, such as insulated gloves and safety glasses. These will help protect you from electrical shocks and other hazards. Thirdly, never work on electrical systems in wet or damp conditions. Water is a conductor of electricity, and working in wet conditions significantly increases the risk of electric shock. Fourthly, inspect your tools before each use to ensure they are in good working condition. Damaged or faulty tools can be dangerous and should not be used. Fifthly, follow the National Electrical Code, or NEC, and local electrical codes. These codes provide detailed requirements for electrical installations and are designed to ensure safety. Common wiring methods in residential and commercial buildings include non-metallic sheaths cable or NM cable, commonly known as Romex, which is widely used for interior wiring of lighting circuits and receptacles in dry locations. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. NM cable is relatively easy to install and is suitable for most residential wiring needs. Secondly, metallic conduit, which is a rigid or flexible metal tube used to protect electrical conductors. Conduit provides excellent protection against physical damage and is required in many commercial and industrial applications. There are several types of conduit, including rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and electrical metallic tubing, or IMT. Thirdly, armored cable, or AC cable, also known as BX cable, which consists of insulated conductors wrapped in a flexible metal sheath. AC cable provides good protection against physical damage and is often used in applications where NM cable is not permitted. Fourthly, underground feeder, or UF cable, which is designed for direct burial in the ground. UF cable is moisture resistant and can be used for outdoor lighting, irrigation systems, and other underground applications. Fifthly, electrical metallic tubing, or IMT, which is a thin-walled metal conduit that is commonly used in commercial and industrial buildings. EMT is lightweight and easy to install, but it is not as strong as rigid metal conduit. Best practices for electrical wiring encompass several key areas, including proper wire sizing, grounding, overcurrent protection, and box fill. Firstly, wire sizing is critical for ensuring that the conductors can safely carry the intended current. The size of the wire must be adequate to handle the load without overheating. The National Electrical Code, or NEC, provides tables that specify the allowable ampacity of different wire sizes based on their insulation type and installation conditions. Using undersized wires can lead to overheating, insulation damage, and even fires. For example, a 14 American wire gauge, or AUG, copper wire with type TW insulation is typically rated for 15 amps, while a 12 American wire gauge, or AUG, copper wire with the same insulation is rated for 20 amps. Secondly, grounding is essential for providing a safe path for fault current to return to the source. A properly grounded electrical system helps to prevent electrical shocks and equipment damage. Grounding involves connecting all non-current carrying metal parts of the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a low resistance path for fault current to flow back to the source, causing the overcurrent protective device, such as a circuit breaker or fuse, to trip and de-energize the circuit. Thirdly, overcurrent protection is designed to protect the electrical system from overloads and short circuits. Overcurrent protective devices, such as circuit breakers and fuses, are installed in the electrical panel to interrupt the flow of current when it exceeds the rated capacity of the circuit. Circuit breakers are reusable and can be reset after they trip, while fuses are single-use devices that must be replaced after they blow. Fourthly, box fill refers to the amount of space available inside an electrical box for conductors, devices, and connectors. The National Electrical Code, or NEC, specifies the maximum number of conductors that can be installed in a box based on the box size and the size of the conductors. Overfilling a box can damage the conductors and make it difficult to make proper connections. Specific applications of electrical wiring require adherence to particular standards and practices. For lighting circuits, it is important to select the appropriate wire size and overcurrent protection for the lighting load. LED lighting is becoming increasingly popular due to its energy efficiency and long lifespan. When wiring LED lighting, it is important to ensure that the wiring is compatible with the LED driver and that the lighting fixtures are properly grounded. For receptacle circuits, it is important to install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of moisture, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect small imbalances in current flow and quickly interrupt the circuit to prevent electrical shocks. For appliance circuits, such as those for refrigerators, ovens, and washing machines, it is important to use dedicated circuits with the appropriate wire size and overcurrent protection. Large appliances draw a significant amount of current, and using shared circuits can lead to overloading and tripping of the circuit breaker. In commercial buildings, electrical wiring must meet more stringent requirements due to the higher electrical loads and the presence of multiple occupants. Firstly, commercial buildings often require three-phase power, which provides more efficient power distribution than single-phase power. Three-phase wiring involves the use of 3 hot wires and a neutral wire, and it requires specialized equipment and installation techniques. Secondly, commercial buildings typically have more complex electrical systems with multiple panels, transformers, and distribution equipment. It is important to design the electrical system to meet the specific needs of the building and to ensure that all components are properly sized and installed. Thirdly, emergency lighting is required in commercial buildings to provide illumination during power outages. Emergency lighting systems typically consist of battery-powered lights that automatically turn on when a normal power supply is interrupted. Fourthly, fire alarm systems are essential for detecting and alerting occupants to the presence of a fire. Fire alarm systems typically consist of smoke detectors, heat detectors, and manual pull stations, which are connected to a central control panel. Adherence to the National Electrical Code, or NEC, and local electrical codes is paramount in all electrical installations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA, and is widely adopted by states and municipalities throughout the United States. Local electrical codes may have additional requirements that are specific to the area. It is important to consult with a qualified electrician or electrical inspector to ensure that your electrical installation complies with all applicable codes. Firstly, the National Electrical Code, or NEC, Article 210 covers branch circuits, which are the circuits that extend from the electrical panel to the various outlets and devices in the building. Article 210.12 requires arc fault circuit interrupter, or FSI, protection for branch circuits that supply receptacles in dwelling units. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Secondly, the National Electrical Code, or NEC, Article 250 covers grounding and bonding. Article 250.32 requires a grounding electrode system for separately derived systems such as generators and transformers. The grounding electrode system must consist of a grounding electrode conductor connected to a grounding electrode, such as a ground rod or a metal water pipe. Thirdly, the National Electrical Code, or NEC, Article 300 covers wiring methods. Article 311 requires that wiring be securely supported and fastened. Wiring must be supported at intervals that prevent excessive sagging and damage to the conductors. Fourthly, the National Electrical Code, or NEC, Article 310 covers conductors for general wiring. Article 310(15) specifies the ampacity of conductors based on their insulation type, size, and installation conditions. It is important to select conductors with an ampacity that is sufficient to carry the intended load. Fifthly, the National Electrical Code, or NEC, Article 408 covers switchboards and panel boards. Article 408(36) requires that panel boards be protected by an overcurrent protective device with a rating not exceeding the panel board's rating. Proper electrical maintenance is essential for ensuring the safety and reliability of electrical systems. Regular inspections and testing can help identify potential problems before they become serious. Firstly, regularly inspect electrical panels for signs of damage, such as corrosion, loose connections, and overheating. Check circuit breakers to ensure they are functioning properly and are not tripping frequently. Secondly, test ground fault circuit interrupters, or GFCIs, monthly to ensure they are working properly. GFCI should trip when the test button is pressed. Thirdly, inspect wiring for signs of damage, such as frayed insulation, loose connections, and exposed conductors. Replace any damaged wiring immediately. Fourthly, use a qualified electrician to perform a thorough electrical inspection at least every 3 to 5 years. An electrician can identify potential problems that may not be visible to the untrained eye. Troubleshooting electrical problems requires a systematic approach and a good understanding of electrical circuits. Firstly, start by identifying the symptoms of the problem. Is the circuit breaker tripping? Is a light not working? Or is an outlet not providing power? Secondly, use a voltage tester to check for voltage at the outlet or device that is not working. If there is no voltage, check the circuit breaker to see if it has tripped. Thirdly, if the circuit breaker has tripped, try resetting it. If the circuit breaker trips again immediately, there is likely a short circuit in the wiring. Fourthly, if there is voltage at the outlet or device but it is not working, check the wiring connections to ensure they are secure. Loose connections can cause intermittent problems and can also lead to overheating. Fifthly, use a multimeter to check the continuity of the wiring. A break in the wiring can prevent current from flowing to the outlet or device. In conclusion, electrical wiring is a critical aspect of building construction and maintenance. Understanding best practices for electrical wiring is essential for ensuring safety, efficiency, and compliance with local electrical codes. By adhering to safety guidelines, using proper wiring methods, and performing regular maintenance, you can help to prevent electrical shocks, fires, and equipment damage. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Proper electrical wiring not only ensures safety but also enhances the functionality and longevity of electrical systems. Always prioritize safety, stay informed about current codes, and seek professional help when needed to maintain a secure and efficient electrical environment.